What is up, ladies and gentlemen? My name is Mike Water, and this is a Ride Academy. Thanks for watching. Thanks for tuning in. If you're watching me for the first time via YouTube, Facebook, or even TikTok, please don't forget to subscribe, like, and also follow my page on Facebook. If you're watching from Facebook, if you are watching me from a YouTube channel, remember to subscribe to my channel so that you never actually miss this kind of videos. If you're watching me from TikTok, make sure that you follow me because I'll be always giving you updates on something that is more valuable. Okay, so now let us dive into something that is actually so much important than anything that you might guess or think of. Okay, so in this simple video, I just want to talk about water. Okay, so this is a compound, universal compound that we all know because water is life. Okay, most of our body, fluid is actually 100% composed of water. So it is very actually imperatively, okay, to talk about something that actually drives our, biological, chemical reaction in our bodies. Okay, so without water, actually, I don't even know how some of the chemical reaction in our bodies, in our cells, how they would just actually, go about. So in this small video, I just want to share with you something that is very cardinal about the behavior of water itself for ionizing, okay, ionization, dissociation of the atoms, the ions of water itself, okay. So as you can see on the board, okay, we have a simple chemical equation which is just talking about water. Now you can see that this is water as a compound, and then you can also see that we have HCl, which is a hydrochloric acid. Now, most of us, we understand that when an acid reacts with a base, okay, so in this case, what we are normally getting is usually a neutralization chemical reaction. Of course, you are not going to see the neutralization chemical reaction there and then because we have not picked the actual things that you have actually seen before. But what you have done is actually to help you understand that if water can act as a base, and then we can also have something that is usually a normal acid, then we can now begin to understand how water now behaves normally when when you try to start trying to measure the quality of water, the pH, the dissolved oxygen, and all these stuffs that gets just dissolved in the water as a solvent. Okay. Now we can see that we form something that is very special, and this is what we call an hydronium. Okay, hydronium ion. Okay, that's what we call an hydronium ion, and then we also have this one, the ion, which is coming from chlorine. Now, coming down, we have a simple chemical reaction also, which is telling us to say this chemical reaction, the third chemical equation, must be in equilibrium. Okay, we all understand the meaning of equilibrium. Equilibrium simply means that both sides of something, of a system, is equally equal, or in terms of there is no resultant effect upon something happening. Okay, so if you say, let's say for example, we have a force that is 100 Newton, and then on the other side we have the force that is 100 Newton. At the end of the day, what will happen is that there is not going to be any external effect or resultant because both of the system are in the state of equilibrium. So if this one tries to change, this one also try to balance that thing. Now, what you must be able to understand is that we are dealing with a chemical reaction, and in the chemical reaction, once you see that there is HA, which I'll explain later, and then we also have H2O, which is water. Now, water is acting as a base. Okay, water is acting as a base. Now, when water is acting as a base, then we understand to say water is going to actually get one atom of hydrogen from the acid and then add it to itself, meaning increasing the number of hydrogen atoms in this one, which gives us this H3 and then the O. And that kind of an ion is just what we call an hydronium. Okay, so you see later in a minute Okay. Now, what is that we're talking about? Now, you can see that what you are forming is what we call normally a conjugate acid. Why is it called a conjugate acid? Because you can see that there was, okay, this water, okay, got an acid and became that, okay, because the addition of one hydrogen atom for it to become H3, that single hydrogen atom came from the acid, and that's the reason why we are calling a conjugate acid, because the derivative of that acid is coming from the acid in the reagent part or in the reactant side, okay, on the reactant side. And then now the fact that an acid is now donating the hydrogen to the water molecule or the water compound, which makes this one to receive that atom, okay, while the acid actually, loses that, okay. So the base gains that, the acid loses that hydrogen atom. Now you can see what is going on is that when you look at the number of hydrogen, okay, must be equal with the number of hydrogen on the product side, okay. So meaning this should be in equilibrium, okay. That should be in equilibrium. So meaning if something is in equilibrium, more especially water, okay, then when it comes to something that we call the pH of water, okay, then we must be able to understand that at equilibrium, water has a pH of 7, meaning we don't have more hydrogen ions, we don't have more hydroxide ions, so that we don't see the fluctuation in terms of the pH levels, okay? So when the pH is at 7 as a level, then that signifies that we have now it reaches an equilibrium state. Now, the fact that there are some certain micro elements, okay, there are certain tiny elements that we cannot see and that cannot even bring about immediate effect once we pour them, once they are in water, okay. They can also bring a corrosive amount or the corrosive effect on the pH of that water. But so meaning most of the time water tends to become acidic, most of the time water tends to become more basic, okay, because that is much more dependent on how much hydrogen ions water is dissociating, or how much maybe hydroxide ions are there, so that at the end of the day, do we have a substance, okay, where water is getting more hydrogen, okay, meaning water is becoming acidic, or do we have a substance in which water is releasing more hydrogen, okay, in order for it to become so basic, okay. So I want you to understand that what we are simply doing is that we are just trying to see how equilibrium of water works, okay. Therefore, you know that the hydronium ion is now getting one extra hydrogen, or rather the water is receiving one extra hydrogen, which is now meaning makes it to become a conjugate acid, and then this acid is losing that hydrogen, which makes it to become a conjugate base, okay, because we have removed the acidic property, which is the hydrogen. Now you can see down below that how do we now mathematically, okay, how do we now mathematically express the equilibrium, the equilibrium constant or equilibrium expression? What is the formula for the equilibrium, okay? So the whole idea is that when you look at this equation down below, we have what is known as Ka, okay? We have what is known as Ka. So Ka equals to what you now see, the square brackets, okay? This is now what we call the concentration. The concentration of the hydronium ion, or the acid, if you like, or I mean the concentration of the part of the acid, okay, and then multiply by the concentration of the base, okay. Okay. So now what happened is that, or rather should I say, the concentration of this conjugate base, which is the same as the concentration of hydrogen ions, okay, because the neutralization chemical reaction only deals with hydrogen ions and then also the hydroxide ion. So we can have this, okay, we can have the concentration of the hydrogen ion and also the concentration of this conjugate base. And then we have down there, we have the concentration of this undissociated acid, okay, which is there. Now, what normally happens is that this Ka is what we call acid dissociation constant. Now, what does acid dissociation constant, or rather, what does dissociation means? Okay, dissociation simply means that dissociation simply means that when you're talking about an acid dissociation constant, or rather dissociation, okay, is the formation of ions, okay. So the formation of ions. Okay. So the formation of ions, in this case we are talking about acid. So once the acid normally dissociates, for example, when you talk about hydrochloric acid, which normally does that. So when it is in water, dissociate there, then you are going to have hydrogen plus that, okay. So what we are looking at now in this Ka equation is that we want to understand what is the constant, okay, of dissociation. So I'm going to say Ka, okay, Ka equals to the concentration of the hydrogen ions multiplied by the concentration of that ions, okay, divided by the concentration of undissociated hydrochloric acid. Okay. So that is how you simply get the value of Ka. So in this case, what that means is that once you find the value, okay, once you find the value, we are kind of determining how that number normally determines how acidic something is, okay? Because for something to dissociate and determine how strong the acid is, obviously you can use the Ka formula to find that number, okay? So thanks for watching. Please don't forget to subscribe. Remember also to follow me on Facebook page, which is just Mike Warrior, and learn with Professor Warrior, so that